This problem and all other Calc 152 problems can be found here at Sarai Studies. Link is in the description box below. We're told to convert this Cartesian point to a polar point. So we really want to go from x, y, which is what they give us, to a polar coordinate with r being the radius and theta being the angle. So that brings the question, well, what is r and what is theta? How can we get those two things? Well, there's formulas. The way I think about r is radius, so I think about the unit circle. And what's one thing I know about the unit circle? That's a really bad circle, but from the center, the radius is always 1, no matter where you go. The length of all of these lines are 1. And what's the equation of a unit circle? Well, it's x squared plus y squared is equal to 1. But this is really Pythagorean theorem. It's a squared plus b squared is equal to c squared. It just happens to be that 1 squared is 1, so we just write 1, but it's really 1 squared. So this 1 here represents the radius. So we're really saying x squared plus y squared is equal to the radius squared. And if we want just radius, then how about we just solve for r by taking the square root that cancels this out, but whatever we do to one side we have to do to the other. So we're left with the fact that r is equal to the square root of x squared plus y squared. Or you can just memorize it. Now for theta, they don't tell you theta is equal to blah, blah, blah. What they tell you is tangent of theta is equal to y over x. It's really sine over cosine. If you really wanted to solve for theta, well, that would just be arctan, and then whatever would be here, which is y over x. But this is the exact same thing. There's really no point in writing this because what you need to do is verbally answer this question. Both of these things you have to ask yourself, well, tangent of what angle is going to give me y over x? Tangent of what angle is going to give me y over x? It's the same question. So there's no point in writing that. Just use this formula and you'll see how we use it. So to find the radius, we take our x and we square it. Then we take our y and we square it. And so that's it. Boom. Radius is square root of 2. Easy as that. Now what's theta? Well, we're saying tangent of theta is equal to y over x, which is just 1. So the question is, tangent of what angle is going to give me 1? Before even looking at the unit circle, you want to know where this point is on the normal xy plane, the Cartesian plane. It would be right here. So when you go and choose your angle by looking at the unit circle, the angle that you're going to choose can only be in this quadrant because the point is in this quadrant. And what's the question we're trying to answer? Tangent of what angle is going to give me 1. So here's our unit circle. I did do a video on how to derive this whole circle without memorizing it, so watch that if you are not familiar with it. But recall that we're looking for tangent of what angle is going to give us 1. Recall that tangent is just y over x, or in other words, sine over cosine. We know that all of our coordinates are x, y, and so on. And the only way that y over x can be equal to 1 is if this and this are the same. So both x and y are the same number and the same sign. Because if this is negative and negative, then it becomes positive 1. And if this is positive and positive, it's also 1. But because our point in the Cartesian plane was over here in the first quadrant, we know that our answer is only going to be an angle in this quadrant. So all of these are eliminated. And the only ones that ever have the same x and y, regardless of signs, are the x angles. Since we eliminated these, we're just left with this one, and that's pi over 4. And you can see if we take y and divide it by x, it's the same thing divided by itself. That's going to give us 1. So theta is equal to pi over 4. And so theta is equal to pi over 4. And that is your answer. These are the same points. It's just that here we describe the point as a Cartesian point, and here we describe the point as a polar point. Now, an important thing to note is that for every Cartesian point, there can be multiple polar representations or polar coordinates that represent that Cartesian point. So this is just one of them. And this lies in the fact that if you remember your unit circle, so here we start at 0 and then all the way over here, that's pi. And if we go half that way, well then that's half of pi, so pi over 2. And the whole idea is if from here to here is pi and we do it again, well then we did pi 2 times. So at this point, we would be at 2 pi. So if we're saying that this angle is pi over 4, the one that we chose, the coordinate is square root 2 over 2, square root 2 over 2. That never changes. This point is in the exact same place with the exact same coordinate. But the label does change because from here to here, we're at pi over 4. But once you keep going and then past the 0, well then you went through the unit circle 2 pi times. And so once you get over here, this is no longer pi over 4, it's pi over 4 plus 2 pi. So then if we did pi over 4 plus 2 pi, well that'd be 4, then pi plus 8 pi, which is 9 pi over 4. So this now would be 9 pi over 4. So same place, same coordinate, it's just a different label. Because now we're not going through the unit circle this way, we've been through the unit circle 2 pi times, and now it's 9 pi over 4. So all you have to do to get other representations is just add, or we could subtract, we can go the other way, we can revert back 2 pi to your theta. So 1 would be 9 pi over 4 if we add 2 pi. Another thing we can do is we can make our negative. So if we do that, make this negative, the rule is that we would have to add or subtract pi from theta. So we would take pi over 4, and let's say we were to add pi, that'd be 4, that'd be pi plus 4 pi, that'd be 5 pi over 4. So then this would be 5 pi over 4. We can also do a mix of both. We can make this our negative, and then we would have to add pi to this, or minus pi, but then we could also represent this once we go through the unit circle 2 pi times. So we can also add 2 pi, and then that would give us another coordinate, and so on. So this is another polar representation of this exact same coordinate. So this is one, this is another one, this is another one. So there's many representations for a Cartesian point. But if we're going from polar to Cartesian, there's only ever one Cartesian point. So this polar coordinate only represents this Cartesian coordinate. This polar coordinate only represents this Cartesian coordinate. So the rule is that this polar coordinate can't represent this Cartesian coordinate and also like 1, 2, which is a different one. It can only ever represent one. So keep that in mind, and I'll see you in the next video. Bye.